physical problems with liquids, etc. One would therefore want any long-term base for human beings to be on a planet or moon. By digging into the surface, one would get thermal insulation and protection from meteors and cosmic rays. The planet or moon could also serve as a source of the raw materials that would be needed if the extraterrestrial community was to be self-sustaining, independently of Earth. What are the possible sites of a human colony in the solar system? The most obvious is the moon. It is close by and relatively easy to reach. We have already landed on it and driven across it in a buggy. On the other hand, the moon is small and without atmosphere or a magnetic field to deflect the solar radiation particles, like on Earth. There is no liquid water, but there may be ice in the craters at the north and south poles. A colony on the moon could use this as a source of oxygen, with power provided by nuclear energy or solar panels. The moon could be a base for travel to the rest of the solar system. Mars is the obvious next target. It is half as far again as the Earth from the Sun, and so receives half the warmth. It once had a magnetic field, but it decayed 4 billion years ago, leaving Mars without protection from solar radiation. This stripped Mars of most of its atmosphere, leaving it with only 1% of the pressure of the Earth's atmosphere. However, the pressure must have been higher in the past, because we see what appear to be runoff channels and dried up lakes. Liquid water cannot exist on Mars now. It would vaporize in the near vacuum. This suggests that Mars had a warm, wet period, during which life might have appeared, either spontaneously or through panspermia. There is no sign of life on Mars now, but if we found evidence that life had once existed, it would indicate that the probability of life developing on a suitable planet was fairly high. NASA has sent a large number of spacecraft to Mars, starting with Mariner 4 in 1964. It has surveyed the planet with a number of orbiters, the latest being the Mars Reconnaissance Orbiter. These orbiters have revealed deep gullies and the highest mountains in the solar system. NASA has also landed a number of probes on the surface of Mars, most recently, the 2 Mars rovers. These have sent back pictures of a dry desert landscape. However, there is a large quantity of water in the form of ice in the polar regions. A colony on Mars could use this as a source of oxygen. There has been volcanic activity on Mars. This would have brought minerals and metals to the surface, which a colony could use. The Moon and Mars are the most suitable sites for space colonies in the solar system. Mercury and Venus are too hot, while Jupiter and Saturn are gas giants, with no solid surface. The moons of Mars are very small, and have no advantages over Mars itself. Some of the moons of Jupiter and Saturn might be possible. In particular, Titan, a moon of Saturn, is larger and more massive than our moon, and has a dense atmosphere. The Cassini-Huygens mission of NASA and ESA has landed a probe on Titan, which has sent back pictures of the surface. However, it is very cold, being so far from the sun, and I wouldn't fancy living next to a lake of liquid methane. What about beyond the solar system? Our observations indicate that a significant fraction of stars have planets around them. So far, We can detect only giant planets, like Jupiter and Saturn, but it is reasonable to assume that they will be accompanied by smaller, Earth-like planets. Some of these will lie in the Goldilocks zone, where the distance from the star is in the right range for liquid water to exist on their surface. There are around 1,000 stars within 30 light years of Earth. If 1% of these have Earth-sized planets in the Goldilocks zone, we have 10 candidate new worlds. We can't envisage visiting them with current technology, but we should make interstellar travel a long-term aim. By long-term, I mean over the next 200 to 500 years. The human race has existed as a separate species for about 2 million years. Civilization began about 10,000 years ago, and the rate of development has been steadily increasing. If the human race is to continue for another million years, we will have to boldly go where no one has gone before. Thank you for listening.
Thank you, Professor Hawking, for that series of insights and a challenge to us all. I believe now, for those of you that wanted to do flash photography, it would be okay for a few moments. And I invite you all to head upstairs for a very nice reception, courtesy of our sponsor, Lockheed Martin. Thank you all.